In this work in progress, we present FlexAR, a tangible augmented reality application for anatomy education. Traditionally, anatomy has been taught in two dimensions, particularly in non-medical fields, such as for artists studying life drawing and physical education practitioners. We will propose FlexAR as a teaching tool for providing students both the written information found in printed study materials and the ability to examine structures in 3D previously available only through dissection or studying of complex physical models. Users of our prototype manipulate a skeletal model of a human's left arm, affixed with augmented reality targets. An AR-enabled device records this interaction through a camera and projects a digital 3D model consisting of the bones and major muscles of the arm over the physical model on screen. Users can then manipulate the tangible model to examine gross anatomy as well as muscle flexion and extension. The user can also interact with a graphical user interface to highlight muscles and display related textual information. Our prototype was implemented using the Unity game engine for handling input, output, and processing of data. Our primary reasoning behind this choice was our need to rapidly prototype and easily deploy to multiple platforms when testing our prototypes. We used the Vuforia AR plugin for Unity to handle registering and tracking of our augmented reality tags. The 3D model of the arm was modeled and rigged in Maya. To test FlexAR, we allowed users to interact with our prototype in a lab environment. We gathered 9 university-level participants from a variety of backgrounds, including art, dance, and computer engineering. We then divided them into 3 groups of equal size. The project was built for 3 different devices: a desktop with a webcam, an Android tablet, and Epson Mouvrio BT200 smart glasses. Each group interacted with one of these devices. For this iteration, we focused on usability, interaction, and user experience. The feedback we received was generally positive. Users listed a number of areas in which they believed FlexAR would be useful. Several students compared it favorably to using anatomy textbooks to train medical personnel. A few mentioned its usefulness as a reference in the process of creating joint systems for 3D animation, and one user who specialized in sculpting expressed interest in being able to view static structures from multiple angles. Users were also asked to list the type of device they felt was best suited to this application. The general consensus was that the tablet was too large and difficult to handle at the same time as the tangible. What we found interesting, however, was the feedback regarding the desktop and the smart glasses. Many users stated the desktop would be ideal for learning as a group or class, while the glasses would be most useful in individual learning. Motivated by the positive initial feedback we received, we are currently furthering our research and expanding our prototype to not only include the arm, but also other key regions, such as the torso. A large tangible would likely enhance the user's sense of immersion into the application and bring us closer to our goal of being able to replace cadaver dissection as an effective method of teaching anatomy spatially. Additionally, we plan to move to the Vuforia SDK for digital eyewear, a software library designed specifically to take advantage of smart glass technology once it is released to the public.